All right, so over operations on functions, they'll finish. If f of x is 8 to the x, and g of x is 4 to the power of 2x minus 5, and h of x is 256 to the x plus 3, then determine the simplified expression. So f, what does this mean? So it means you want f of x times g of x, right? So f of x is 8 to the x, and g of x is 4 to the 2x minus 5. So how can those be combined? Common base. What might be the common base? Maybe not. 2. Like as soon as I said 4, I knew that was. Okay. So what's 8 with a base of 2? So it's 2 cubed to the x, and what's 4? Okay, 2 squared to the 2x minus 5, right? So 8 to the x is what? 2 to the 3x, and this is 2 to the 4x minus 10, which is 2 to the power of 7x minus 10, right? So we have power to a power, right? 8 is 2 cubed. 2 cubed to the x is 2 to the 3x. We multiply. And then we have, when you're multiplying powers with the same base, you add the exponent. So there we go. We've got that and the domain. Is there anything unreal about this? Any x's you can't have? Can x be 0? Can 7x minus 10 be 0? Can 7x minus 10 be... What can't 7x minus 10 be equal to? There's nothing it can't be equal to, right? It's an exponential, right? It's not a radical. It's not a log, right? A log function, you have to have a positive base and a positive value. Okay, m of x. Determine the simplified expression and state the domain for m of x if h of x is equal to f over m of x. Okay, so what's h of x equal to? Let's do this over here. What would I immediately say about m of x? Okay, so m of x cannot be 0. What well, okay, we don't even know what m of x is yet, but we need to keep in mind that it can't be 0. The restriction is on x, right? I mean, the restriction is m of x can't be 0. We need to then figure out, is there a value of x such that? Probably not if it's a exponential, right? Because they can't be 0. Okay, so what's m of x equal to then? F of x over h of x, right? Because we know f of x and we know h of x, so we can do that. What can't h of x be? Okay, but h of x is an exponential, so it can't be 0 anyways, right? But we're good. There's no restriction so far. Okay, so m of x is equal to 8 to the x over 256 to the x plus 3. Can those be expressed with a common base? What is that base? 2. So 8, we've done 256. Is that 2 to the 8? Right? And I mean, if you don't know that offhand, you can play with it, right? You do 2 to the 7th, oh, too small, 2 to the 8. Yeah. Okay, so what do we got? 2 to the 3x over 2 to the what? 8x plus 24, which gives us 2 to the... Now we can do it in one fell swoop, which gives us a good chance of getting it wrong, or we can do it in 2, but go ahead. What is it?
Negative 5x minus 24.
Yeah. So if you need to do another line in there, just write, 3x minus... Okay, if you need to do that, by all means, right? I mean, nobody minds if you do too much. Sometimes too little is not good, right? Just, pretend that whoever's looking at your test afterwards, like a kid in another class or something that they're looking at, you're not confusing them by having done too much in one step, right? So just kind of look at it and just say, okay, does it make sense? Like, did I do too much in one step? And if so, show another step. Okay, what do we say? X belongs to the reals, right? Because you can't make this 0. 2 to some power, you can get close to 0, but you can't be 0. Okay, any questions on 6? Just to annoy the people on YouTube. And now some sinusoidal stuff. The graphs of y equals f of x and y equals g of x are shown to the right. State the equation of y equals, so what is y equals f of x? Okay, what kind of a function is it? It starts at p. Cosine. Okay, goes to 4, so it's what? 4 cos, what's period? 2 pi, so we don't have to, b is 1, right? Okay, what's the midline? 0. Okay, so it's just 4 cos x. Okay, so y is equal, so f of x is equal to 4 cos x. What's g of x? Okay, amplitude is 1, midline is 0, right? A is 1, D is 0. Period is pi. So B is 2, right? 2 pi divided by pi. So B is 2. It's what kind of it's a unshifted sine, right? So given the choice, so what is that? The sine of 2x? Given a choice, we could write this as a cosine, but, why? Okay. Given a choice, if I can write it as with no phase shift, I'm going to write it with no phase shift, right? So this is an unshifted cosine. This is an unshifted sine. Okay, and then we just, if it's unshifted, C is 0, then you just do your ABD. Do the ABDs. Determine a simplified expression for f of x over g of x. So what can't g of x? What's the restriction? So let's start with this. G of x can't be 0, which means the sine of 2x can't be 0, and we can probably actually pull that off of here, right? Just like every pi over 2. Okay. So x is not equal to n pi over 2, where n is an integer. Okay. You just get that off the graph, right? 0, pi over 2, pi, 3 pi over 2, 2. Yeah, okay. Right, we can see what's going on. Okay, simplified expression. So what do we have? We've got f over g of x is equal to, so what do we say? 4 cos x over the sine of 2x. All right, where's my formula sheet? What's the sine of 2x? That's 2 sine x cos x. Does it make sense to do that? 4 cos x over 2 sine x cos x. Okay, so cos x is, okay, what do we got? 2 over sine x, which is what? Cosecant. With your restriction, right? If you do the restriction here, it's sine x can't be 0, cos x can't be 0, right? But that's still this restriction. Okay, so 2 cosecant x. State the domain of any cosecant. No, that's fine. Okay, state the domain of f of g. Oh, well, so we've got it, right? The domain is just kind of this, really. So, okay, so let's throw D for domain. D for domain. Okay. Ready to move on? Is there anything to move on to? Oh, there still is another. log. So you notice what we've done now, we did what? Some radicals, we've done some trig. Did we do some rationals? I can't remember, that was so long ago. The graph of y equals log 2x is shown as a dotted graph below. The graphs of y equals f of x and y equals g of x shown are translations of the graph y equals log 2x. State the equations of f of x and g of x. Okay, so what's going on here? So it looks like this was, what do we do to get to? Horizontal translation, 3 units to the left, right? So to go from the dashed line to f of x, it's a translation 3 units to the left. Okay, so how do we do that? What gets replaced with what? Okay, so it's log base 2 of x plus 3, right? If x is replaced by x plus 3, we have a horizontal translation left 3 units. Okay, cool. What's g of x? So, okay, you move 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3. So it looks like it's just been moved, right? Okay, so what is it? X minus 5. And it's a base 2 log, right? Okay, are we done? Oh, dang. Write a simplified expression for each of the following and state the domain. F plus g of x. Okay, so what's f plus g of x? Log base 2 of, what was it, x plus 3? Times log base 2 of x minus 5. Okay, formula sheet. Oh, it's plus, right, sorry. That's good, it's going to make it actually easy to do that. Okay, formula sheet to the rest of you. It says if I'm adding 2 logs, then what do I do?
You multiply.
Yeah, it's log base 2 of the product, right? Okay. So, log base 2 of... I don't think it hurts to put that into parentheses, right? It makes it sort of more obvious that it's log base 2 of that expression. Okay? There are times, and we had this sort of discussion, that's right, like when you have this, x minus 2 log 4, right? And you write x log 4, that's pretty obvious, but when you write, what's that mean? Either do 4 times x and then take the log. Okay, what do we want it to mean? In this instance, we want it to mean this, right? Do the log of 4 and then multiply it by x. If we write parentheses like that, then it's obvious, right? If we write it like this, then it's obvious. If we write it like this, then it's ambiguous. And here's how I'm going to interpret it. That's the only way I can interpret that, right? Is to say I have to do the 4x and then take the log of that. And that's wrong. Okay? That's clearly not what we meant. So if you are in this situation, write it like this. It's unambiguous. X times the log of 4. You write log 4x, you're going to have to put brackets around the log 4. Don't put yourself in that position. Seriously, just write it like this. Okay? Because you wouldn't write, I mean, the full thing should be this. And you're not going to write that as, right? You would never write that. Is that a 42? Is that you could write this, okay, log of 4 times 2, which is what we want, but you shouldn't write that, right? And if you wrote this, then that's a log of 8. So, anyways, just be aware of how you're writing things. And I didn't write them, you know. I write stuff unambiguous, right? When I show you how to do stuff, that's how you want to write the stuff. Okay, anyways, what are we supposed to do with this? What do we know then? Domain. So what is it about x squared minus 2x minus 15? Has to be greater than 0. When is it greater than 0? I mean, luckily we've got the factored form, right? So we've got a negative 3 and a 5. So what can I say about x? So x is greater than 5, or? Less than negative 3. Right, and that'll give me a positive value, and then we're good. F of x minus g of x. So, okay, what's that? Log base 2 of x plus 3 minus log base 2x minus 5. What do we do with that? So log base 2 of this. That's simplifying? Not really. What do we know about x minus 5? So x minus 5 can't be 0, right? So x can't be 5. Now, we know that this expression can't be negative, right? Which means that either both of these guys are positive or both of these guys are negative, right? So then we need the case where x plus 3 is greater than 0 and x minus 5 is greater than 0. So that leads to x is greater than negative 3 and x is greater than 5. So what are we going to say then? X has to be greater than 5, right? Okay, now we know it can't be equal to 5, right? So x is not equal to 5. Okay, so domain x is greater than 5. Okay, and what's the other case? They both be negative. So that is x is less than negative 3 and x is less than 5. So that x, if you think about it, really should come out kind of the same domain as that, right? In the sense that these both have to be positive or both negative. Okay. Done. One down, one page to go. Composition for all the music students. To do composition of functions.
You this tomorrow?
Yeah, no, it's today. Only maybe you weren't here at the beginning when I said, we're going to do the first page of composition of functions. First page being the left side and the right side. Okay, because we're going to try and work ahead so that we give you time to actually look at the tests that are online before you come in and write the test. So, subtle dig. Right? So,
Are you going to upload those before the long weekend?
we uploaded them last time well in advance, so I don't know. Yes, we will. When's their long weekend? Oh, like this. So far, we have combined two functions, f of x and g of x, through the operations of addition, subtraction, multiplication, division. Another way is through composition. So f of, this is read f of g of x, f of g of x. And this is read g of f of x. And it means evaluate this, do the g of x, and then put it as the input to f. Okay? So two functions are given by x squared minus 2x plus 3 and g of x is 3. Determine g of negative 2. Wow. Okay, we're back to grade 10. But it does say determine, so show your work. Okay, so g of negative 2 is negative 7, right? Easy peasy. Use your answer from part A to determine f of g of negative 2. So f of g of negative 2, okay, wait a sec, what's g of negative 2? Negative 7. So f of g of negative 2 is f of negative 7, which is negative 7 quantity squared minus 2 times negative 7 plus 3, which is 49 plus 14 plus 3, which is what? 6, 52, 66. Now, can we get there in one step? That's what the determine a simplified expression. So if for some reason I had to compute a lot of these, then I might want a simplified expression, right? If I'm doing 1 or 2, it's just sort of like, you know what, I'll just work them out individually. But, you know, if I were writing a computer program to do this or something and wanted it to execute faster than if I could come up with one single function instead of having to combine, then we could save microseconds. Maybe even petaseconds. We wouldn't really save any appreciable amount of time, but in the old days, you would have saved time. All right, what do we got? F of g of x. So what's g of x? 3x minus 1. So what's f of g of x? What do we do? So we're going to do f of 3x minus 1. Okay. Now what does f tell us to do then? What do I do with this 3x minus 1? Well, I'm going to square it. Right? The function f says take whatever's in here, square it, go minus 2 times it, and then add 3. So f of g of x is simply f of 3x minus 1. The function f tells us square the input, subtract 2 times the input. Okay, so we get okay. So far, what's the mistake? Yeah. You can't square a binomial. Okay. What's it worth if you square a binomial wrong? You get 0 on the whole thing. Right? I had to do that the other day to 20-1. It's like, yeah, it's 3 marks. Too bad. Right? Like, you cannot make that mistake. You can't do it at the 20 level. You can't do it at the 30 level. All right, and then we just simplify this. What do we got? 9x squared minus 12x plus 6. Use your answer from part C to determine f of g of negative 2. So this is f of g of x. So 9 times negative 2 squared minus 12 times negative 2 plus 6.
You can simplify that if you take a 3 out. You don't need
Factoring is not simplifying. No, don't factor. That's complicating it.
You're just taking out a 3 though.
How? It's not equal to 0. I can't divide by 3. The best you can do is go 3 bracket 3x squared minus.
That's what I mean.
That's more complicated than this. Right? Because then it says, okay, what does this say? How many operations? Square a number multiplied by 9. Subtract 12 times the number, add 6. There are 5 operations there, right? You want it as square a number multiplied by 3. Subtract 2 times, or whatever, 4 times the number. Add 2, then multiply by 3. You're at 6 operations at 5. This is simplified form. Factored form is not simplified. It's called factored form. Simplified form, factored. We do not want a factored form. Okay? Not in this instance, right? If I'm doing something with it, I have to divide, whatever, then maybe. Okay? But no. All right, so what is this? 66. Not surprised. I mean, it better be 66. If it's not, there's something wrong. How do your answers be? Surprisingly. They are the same. The function f of g of x is a composition of functions. F of x and g of x is formed by substituting g of x for blank in the equation of, what are we substituting? G of x for x in the equation of f of x. The function f of g of x is read f of g of x and is denoted by f open circle. Okay? If it's a closed dot, what is it? Multiply. An open circle is composition. Okay? I read this fog sometimes, right? Because it's like an O. Okay? Fog. Similarly, the function g of x also denoted by, so how would we read this? Goth, right? Like the art teacher. Except not spelled the same. This is where you could say, hey, Mr. Composition of Functions. Is formed by substituting what? Okay, you're going to substitute f of x for x into the equation g of x. Note, fog and goff is not to be confused, or fog is not to be confused with the product. Okay, so open circle. If you say fog, then you're not going to say multiply, hopefully, right? It's composition. It's f of g of x. Table values below. This is kind of a neat way to do these types of questions, right? So fill in the table. Go ahead. Figure it out. If it does not exist, say, good thing it's made of lexane or some unbreakable polycarbonate. BPA free, no doubt. I don't think it cries. You can run a car over it. It seriously might not break. I wouldn't run a tank over it. It would break. Used to. I don't know. I think they moved them, right, from the CFP. Like Lord Strathcona horse, I think. Because anything that was a cavalry unit became armored. Yeah. Right? Because they did away with the horses. So, no, I was just going to go infantry. I wasn't going to go armored. There's no place for tanks in the modern world, right? Like, seriously, one guy with a shoulder-held whatever can take out a tank. So, you know, one little A-10 Warthog can take out a tank. Wearing depleted uranium shells. Nasty things. Well, they'll penetrate a tank. That's nasty. Anyways. So, x is negative 2. G of x is 0. So what do we want? We want f of 0. F of 0 is? Right? Okay, that's how you do it. Okay, g of f of x. Okay, x is negative 2. F of negative 2 is 3. This is now a 3. Well, g of 3 is 6. 6. Okay, do the rest. I shall pause this so that people don't have to watch you doing this. Not that they could. Okay, any questions about this? Like, why is that line this? I don't get it. Now's your chance. Yeah.
Just like go through the steps one more time.
Okay. So fog is f of g of x, right? Okay. So when x is negative 2, what's g of negative 2? 0. So that goes, now we want f of 0. So we go down to where x is 0, and we do f of 0, and that's 1. Okay? So g of negative 2 gives me 0, and f of 0 gives me 1. Okay? And then g of f of x, okay, forget this, it doesn't exist now, right? G of f of x, so x is negative 2, f of x is 3. That goes as the input to g, so I want 3 as the input to g, which gives me a 6. Okay? So all we're doing is just saying there's an input to this function, right? It's composition, so I put something into f of x, right? I put a negative 2 into f of x, I get out a 3. So this goes g of f, here, let's trace this out. G of f. So this one here is g of f of negative 2, which is g of 3, okay? Because I don't have to work this out. They didn't give me a function. They just said when x is negative 2, g is 3. G of 3, and then I go down here, g of 3 is 6, and that's what goes there, okay? Now that does not exist, okay, so for this one, it's g of f of 0. So f of 0 is 1. So I want to put 1 into g of x. I need g of 1, but I have no 1. So I can't do it, so it does not exist, right? So 1 is not an element of the domain of this function. So when we at the next page that we're not going to do today, the next page is on domain, right? What's the idea? Well, this function f of x may have outputs, but the outputs have to be inputs to g. So this output's a 1. That's not an allowable input to g. So I can't do it. And then the same here, right? Like g of x, so g of 3 puts out a 6. I want, well, when x is 6, I want f, I can't do it. It doesn't exist, right? So it's not in the domain. Okay, that's the idea there. The graphs of y, so now we can get the outputs from the graphs, right? Use the graphs to evaluate each of the, is this the last thing? Yes, okay, so this is the last thing we do. Okay, use the graphs to evaluate each of the following. I gotta shrink this down, but you can start on it, right? Do the entire page there. Okay, see the entire page. So use the graph. So let's do the first one. F of g of negative 1. So what's the first thing we do here? You find g of x. You find x is negative 1. So g of negative 1 is 5. Okay? And now I want f of 5. So now we go to x is 5, and f of 5 is 12. Okay? Make sense? Okay? So g of f of 4. So let's do f of 4. So I go to 4, right? My input to the function f is 4. My output is 5. My input to g is a 5, and the output is negative 1. Okay? Do those two make sense? I mean, if those two make sense, then the rest should be. Okay. So then just keep going. Right? I'll just mumble my way through this while you're doing it. So f of g of 1, so 1, g of 1 is 3. I want f of 3, f of 3, and f of 3 is 0. G of f of 1, okay, so f of 1 is negative 4. And g of negative 4 is 8. G of f of 0 is g of, okay, f of 0 is negative 3. And g of negative 3 is 7. F of g of 0, so the other way around. So now it's g of 0 first. So g of 0 is 4, and then f of 4 is 5. Then it gets complicated. I need a sip of my drink of the day. Cold coffee with cinnamon and chocolate. So I want f, okay, so what are we going to do here? I want f of g of x. So basically I want f of something to be negative 3. So I'm looking at drawing a line down here, not up there. So I have, f of 0 is negative 3, and f of what? 2. F of 2 is negative 3. Okay, so I need an x value such that g of x is going to give me a 0, right? So again, I've got f of g of x is negative 3. So f of something is negative 3. So I got to figure out what those somethings are, right? F of 0 is negative 3, f of 2 is negative 3. Now I say, fine. That means that I need a 0, right? So I need g of x to give me a 0, which is here. So that means that x is equal to 4, right? And I need g of x to give me a 2, which means that x is 2. So x is 2 or 4, right? Let's clean that up. Okay, so does that make sense? First, just say, what are the inputs? Right, what we're doing here is saying, what are the inputs to f that will give me a negative 3? Draw a line along negative 3 and say, okay, if you put in x is 0, you're going to get out negative 3. If you put in x is 2, so f of 0 is negative 3. Okay, what does that mean? So now you back up one step. So that means I need g of x to be 0. Okay, so you go along the 0 line and you say, when is g of x 0? Okay, 4. Or I need g of x to be negative 2. Sorry, 2. So I go along the 2 line and I say, okay, there it is, when x is 2. Okay? So now try these two, because they're similar. Okay, and you might have to write it out, right? You can't do it in your head. There's like two different values and stuff like that, so don't try and do it in your head. Just say, so this is g of f of x. This is notation I prefer. So if I see Goff, I write g of f of x. Okay. If I see f plus g of x, I write f of x plus g of x, right? It just allows me to just get, okay, this is where it is, and then. Okay, so g of what gives me -1? Well, first clean off all the junk. Okay, so g of 5, which means now, going here, I need f of x to be 5. So that's -2 and +4. Okay, so that's for this one. And this is the associated work that goes along with it. Okay, g of what? 9. Okay, so for the last one, g of f of x is 9, right? So I say, fine. G of what is 9? G of -5. Okay, what does that mean? It means f of x has to be -5. When does that happen? Okay, does not exist. You can't get a -5 out of the function, right? F of x can never be -5. So there is no value of x, right? So actually you could write x as the empty set, I guess. So empty set, do some brace brackets with nothing in between, or throw in a 0 with a slash through it. It also means the empty set. Or just say no solution, right? Any of the above are good. Okay, so are those three good now? Might have to sit and stare at them for a while. Okay, if need be, go back to the video. Am I actually still, okay, I'm actually recording, so it has all been explained, right? Or come into Wise Time if you're still having problems. Seriously, any problem you have in Wise Time can probably be worked out in 30 seconds or less, right? Don't just think, oh, I go into Wise Time, I'm stuck for half an hour. No, you're not. You can come in and just say, got a problem with this one. There, that should be a 3. Oh, I thought it was a -3. Thanks, I'm out of here. Okay. Same thing in Henry's, right? You don't have to stay. It's like, oh, I go at 3:30, I got to stay till 5. We're not locking the doors. Okay. A lot of you have been to Wise Time. Have you actually spent like 30 minutes working on a single question? No, right? It's just like, I need some clarification on this. That's really all you're asking for, right? I just need to clarify this. What is the issue? Oh, so the issue is that f of x cannot equal -5, right? That's the issue. Okay. Right. So tomorrow, because we got to do really all the domain together, then we'll do that tomorrow, right?